As we said before, we can factor out the delays using this, what we are calling the delay metric, even here. So if for faster implementation, so we are not going to use symbolic mathematics, we're not going to use SymPy, and we can again rewrite this matrix here as a polynomial with matrix coefficients. So we have this delay matrix z, so here we have the terms of z to the power of 0 plus this matrix z to the power of -1, and we store this matrix coefficients on a three-dimensional tensor. So we will store this matrix coefficients on a three-dimensional tensor. So one tensor for z to the power of 0 and one for z to the power of -1. We can factor out this delay matrix, and what remains is a matrix which only contains the coefficients of our baseband prototype filter, which we'll call the folding matrix or the filter matrix Fa. So is given here by equation 4, and so we get that Fa of z is equal to Fa times d of z. So we have this is the Fa, this is the d of z, and when we multiply them we get this Fa of z.